Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last video, we looked at how variables get passed into functions and kind of a mental model that you can use for the way that memory works in Scala. This is kind of the standard way of passing things around. The standard would be called the semantics, what it means when you pass a variable into or when you pass an argument into a function, and in particular if it's associated with a variable name. In this video, we're going to look at an alternate way of passing things. So Scala basically provides two of these semantics for passing things. One is the standard way in which you pass a reference to an object, and the other one is called pass by name. And pass by name has some interesting properties to it, and it gives you some nice power. And so I want to look at what you can do with the pass by name semantics inside of Scala. This also turns out to be significant for understanding some of the things that we're going to talk about in the next video for some of the other built-in function or built-in methods on collections. So I guess in some ways to motivate this, let's consider the idea of I want to fill an array with, or actually how about maybe build a list. Last time we did filling arrays. Let's do build a list that has a particular number of elements in it, and I want the elements to have some value. Now what I'm going to change about this in just a second is I'm going to want them to be random numbers with different values. But to start off, let's just make a build list, and it is supposed to let's pass it an n for a value, and I don't know, how about we call it x as a double, and so this is going to give us back a list of double. And the idea here is, well, if n is less than 1, we're going to return nil, else we are going to return x const onto build list of n minus 1. Okay, so this is a simple recursive definition, except it would really help if I passed in the second argument on my recursion that allows you to build a list of a particular length, and you pass in a value. We can see this work. Let's make a list with 5 elements that are each have the value of 99. Now, the fact that lists are not mutable, it's somewhat questionable as to whether there's any value of creating a list of a particular length where all of the values are the same. We could have done something similar for an array, though the construction of the array would have had to have been separate. But now let's think about what happens if I want this to not be just 99. I want this to be a random value. So we can easiest way to make a random double is to call math.random. And math.random gives you back a random number between 0 and 1, which is inclusive in the 0 and exclusive on the 1. And you can see what this does. It gives us back a list with the proper number of elements, and it uses a single random number for all of the values. Well, this is exactly what we told Scala to do, because remember the normal semantics here is that this expression gets evaluated. It becomes an object, a value in a box, if you will, and that value in a box gets passed by reference to the function. So in this case, the call to math.random gave 0.829, etc. And so that one value of 0.829 was used for every element in the list. But that's not what I want. Okay, what I'd really like to do is have it so that this can have different values for every element in the list. Well, how could we do that? Well, the way, given what we know, would be to pass in, instead of x just being simply a double, I'm going to make it a function. Okay, and I'll call this build list f for function. And so now x is a function. Now notice this is a function that takes 0 arguments, and gives us back a double. And so the body of this function will look pretty much the same. The one difference here is that I need to say I'm evaluating x. Oh, and I need to use my altered function name. Okay. So now what if I wanted to use this call to build a list that has 5 values that are all random numbers? Well, I can do that, but I have to somehow pass this in as a function that can be evaluated here. How about we just do def make random equals math dot random. Oh, it still got evaluated first. Value. Oh, I know why. This would make sense. Let's go back to my first. This is the correct invocation here. I left off the F again. Okay. Now you can see that if I pass in the function, unit goes to math.random, this winds up building a list, has 5 elements, but they are all different. They are all different random numbers. Okay. There are a number of reasons why having to include this is, I don't know, burdensome, less than ideal. And so the basic idea of pass by name semantics is I want to be able to do the same type of thing, but not have to explicitly say that this is a function. Okay? I want to be able to pass in and just give it some code and have it treat that code as a function. In fact, it's given the name a thunk, which is it wraps the code inside of basically inside of a little function, and then it evaluates that function. So instead of calling our build list f, I'm going to call this build list n for pass by name. And the only change here is I get rid of the parentheses. So what does this mean? Well, this new type over here, it's just rocket double. This is what indicates to Scala that something is passed by name. Okay? And the fact that it has a rocket and it kind of looks like a function is intentional, because it very much is, but as indicated by the fact that I took away the parentheses, this is a function-ish thing. It doesn't actually take any arguments, and you don't have to you don't have to have parentheses to make it so that it evaluates. And so if I change this to using the inversion, and I do that, now I have build list in. And I can come back up here. Now when I call build list in, I actually go back to my original syntax. Okay. I just say the second argument is math.random. So the difference between pass by name semantics and the normal semantics of passing is in the normal semantics of passing, this was evaluated and references to that value were passed into this function and then possibly recursively down. When I use pass by name, though, by putting just this rocket in front of the type, this is not evaluated. Instead, it is wrapped up in a thunk, and every time that x is used in here, like this, every time you get the value of x to do something, it evaluates this code, okay, whatever that code might be. And to help you see this, let's do var I equals 0. And I want to do something where let's first do this with our normal build list. Except what I'm going to pass into here is that. Okay, so I'm using curly braces to make a block of code. And I need this to be a block because I actually have 2 things that are happening in here. One, I want I to be incremented. And then I want to give back a random number. And remember, when you have a block of code, the value of that block is whatever the value of the last statement is semicolons, you should recall, are used to separate statements. We generally omit them in Scala because Scala infers them. Every time that a line ends, Scala checks to see whether or not it is valid to put a semicolon there. Because I'm putting this all in one line, though, I need to put in a semicolon to explicitly break between my two statements. So I do this. We get a random number, but we get 5 copies of this random number. And if we look at I, it's 1. Why is this? Because when we use the normal passing semantics, it took this expression here and evaluated the whole thing. So it did this once before calling build list. So it added 1 to I, and then it picked a random number and it passed that random number in. And that was the only time this code got executed. Now if we set I back to 0 and we call this same thing, but now we're going to use our pass by name version. Okay, so in this case we're using the pass by name semantics instead. The first change is the thing that we were going for, is the fact that all of the values in here are unique because this math.random actually got called 5 different times. Every time that the function used x, it reevaluated that. And we can see that explicitly by looking at I, and I is now 5. Because the thunk here was not just the math.random, it was the entire block of code. And so every time that a new random number was generated, I was incremented. So hopefully this illustrates to you the difference between the regular semantics and the pass by name semantics. The pass by name is kind of like passing just a little bunch of code that's going to be executed every time. And for reasons like this, okay, this would have been, other than to get this type of result with normal semantics, we would have to pass in a function, as you saw, and then use there's some syntactic overhead to that. But using pass by name, we're able to get those results of having different values, of having the code that's used every single time, and make this work. Instead of doing this with a bunch of random numbers, what if I wanted to fill this in with numbers that were read from the keyboard? Well, we can do that too. Instead of passing math.random, I can say read double. Now, this is paused right here. I'm just going to enter 1 through 5, and that comes out. If this weren't passed by name, it would only read 1 double. In fact, we can do that. If I get rid of that, I'm going to type in 7 and hit enter. It only read the double once because for normal semantics, it gets evaluated and then passed in. And that 1, 7 got duplicated 5 times. For the pass by name semantics, though, this is not evaluated at this point. It gets passed in to the function, and then every time that it's used, it gets evaluated. And because we said it was going to be used 5 times here, we actually get 5 unique values, and they were the things that I typed in. So that's a brief introduction to pass by name semantics. It's likely that we won't use that all that much in here, though there are some cool things that you can do with it. But it's definitely needed for the next video because we're going to look at some of the built-in methods on collections, in particular the fill method, which uses pass by name semantics. In fact, it does basically exactly what we just did here, but does it through pass by name. So you kind of needed to understand what that does beforehand. So that's it for this video, and we'll see you again soon.